right, you guys check it with your decimal equivalent?
Yeah.
Oh, no.
It is.
Off by less than 10 to negative 3. Oh,
Thanks, Hans.
it's a little off.
You're welcome to speak.
I'm not sure by how much.
By less than 10 to the negative 3.
Did y'all get 3 minus 1 over 27?
I'll take your credit. I'm guessing it was your
Ain't that right, Caroline?
Yes.
ISIS.
I'm so proud of you, Caroline.
That's disturbing.
ISIS? So the person named Isis Shower who just went to prison.
Okay.
Probably my cousin. Never met him. Well, Barbara says Mexican, so if I go to San Fernando Valley, $10 I'm down bound to run into one of my cousins I just don't know.
It's the same thing. Stuff you. Because it's oh, yeah.
Wait, it's 27 squared.
Yeah. Oh, thank you. Thank you.
No problem. So
That makes sense why the error. I was like, how is the error so small? That was pretty big.
Yeah.
Oh, I didn't see this. That better?
Yes.
Yeah. Hold on, I'm double checking him right. Is that good?
Yeah.
Okay,
Wait,
yeah.
shouldn't it be?
26.
26?
Whoa.
Approximately equal.
Oh, thank you.
How do why? If you simplify, what is 27 squared?
if I left it in, no.
Katrina, go.
Before putting in the 26, like, I got like, just like 1 over 9 times x squared, or times x.
It should have been 1 over 18 times x. I forgot to square the 27. Cubed root of 27 is 3, but it was squared.
So 9.
Times 3.
Yeah.
Oh, I did times
There you
3.
You see that?
Yeah.
Now, why is the x just 26?
Next time,
and not
next time.
Because remember our cubed root is our function. So this is f of just 26.
Oh.
So x is 26 when f is the cubed root of x. Oh, because of y minus 3? Y minus y.
Oh, because like then I distributed, stupid.
Guys, what were the decimals for each?
No idea.
2.963. That's approximately 2.962.
Oh.
Not bad. Not bad. A little closer than those of you guys yesterday that were like, yeah, just choose something and make up a decimal.
Yeah.
All right, differentials time.
Yay.
Differentials time.
Is everyone else excited?
Yeah.
Question. Whose notation, which founder of calculus,
No idea.
whose notation involved differentials?
Newton. Was he even a founder of calculus? Yes. The French guy.
It was a Greek mathematician and philosopher who actually discovered calculus, but his book was
Wasn't
written.
that's not like
He didn't discover calculus, but he
The
did
French
discover
guy.
some of the
Fundamental biology.
fundamental ideas.
Lafayette. The French guy. Is there a French guy?
Is he French? I don't think he was French.
Lafayette.
He
Lafayette.
was European. I thought he was German.
Oh. Einstein.
No one remembers that they're founder of calculus. How about that? Instead of founder, father.
Newton.
That's one. Who is the other one? The
Einstein.
guy who actually published first. Not Descartes. Good guess though. Not
The hospitals.
A guy named Calculus.
Is there something named after? Is there a forever party named after him?
There are crackers named after him.
Quaker.
Saltine.
Triscuit.
Not America.
Wheatons. Professor Wheatons.
Bacon.
Leibniz.
What?
I said it wasn't American crackers.
How do you
I don't know. They're crackers. What? You asked if there's something named after him. We don't care.
Coffee.
I just
It's a important fact.
Those are crackers.
Dude, Crackers covered in cookie or chocolate.
No, they're crackers. They're cookies.
No, they're crackers. What's the difference? No, they're crackers.
Leibniz. There was Newton and there was Leibniz.
Those crackers, they just add salt to crackers. Not all crackers are salty. Are graham crackers salty?
I don't know. In the video that the guy did online that we watched last year about the two fathers in calculus, there were like Leibniz crackers that pop up on the
I
screen.
think people learn how to argue with me by now.
That's the only reason I know that.
On DYDX.
Anyway, he did the dydx notation.
I agree.
Calm down.
Wait, the homework was.
He did, calm down. No, see what? He did the dydx notation with differentials, whereas Newton did the f prime notation.
Who printed that? That's funny. Noah? I don't understand it, but I like it.
Wait, didn't I say?
That's his idea for the sweatshirt, so now I'm asking for other ideas.
I like it.
Due by next Friday.
don't get it.
Wait, what? Oh, do we get
Due by next Wednesday.
What is the,
We're doing the cosplay.
what is the number when you solve it?
I don't get it.
Are you doing?
If we're getting a sweatshirt here.
Please let us do Cosby this year. Please.
You need a t-shirt.
Just do Cosby, but his face is all blurred out.
Only we would
Wait, so
know.
Miss D, if it's due by next week, that means, does that mean we're gonna have to switch soon?
Yeah.
Oh,
Yeah.
we're gonna have a sweatshirt this semester?
I'm only sorry.
I'm gonna make my
We're in
own.
one class, hopefully we can actually agree this year. Last year was horrible.
Cause no one wanted, cause freaking Ryan Murphy wanted to be like pretentious and wanted one that no one else would get. Even
It
though
was
second
so
number one.
funny though.
Is it the one?
Ryan Murphy was like, no, it has to be the only one that calculus kids would get because we're smarter than everyone. I'm like, Ryan Murphy, calm down, it can be just something funny.
Okay, there were a lot of people that had a lot of different.
That was
They
good.
didn't understand.
Katrina will totally take responsibility. I wanted something.
Katrina wanted something funny.
Except for Tangerine. Tangerine right
No, Cosby was funny.
Wait,
Alright.
it would on the
It's like
Sine B
over tangent,
over tangent B.
right?
Yeah.
Yeah.
Sine B over tan B is Cosby. Alright, guys, we're recording. You should actually be doing everything. So, we know how differentials work. Question.
I don't know if it is.
Question. How can they be applied? You remember? Before I go to the next slide?
Oh my gosh, I forgot about that.
What's delta in math?
Change in Y.
Change in. Like, how far off? Like, how far off an approximation is from an exact? And what do we say how far off is measured in? You guys should know from science classes and labs. Yeah, error. Good. Error. So, delta y can approximate error, which can be very helpful. But first of all, dy, super easy stuff, right guys? How did you dy at the examples down below?
You
Derive and then multiply by.
Okay, that's great. Prove that you can derive.
2 sine of 5x times cosine of 5x times 5.
Hence,
10 sine of 5x cosine of 5x, which is probably a trig identity.
That probably is, yeah.
Doubling
Cosine of 5x.
doubling will do.
of
You're missing a 5.
No, not doubling will cosine.
sine.
This-
Cosine 5x?
Yeah, thank you.
Oh,
No one listens to you.
Technically, it's 5 sine, 5 sine of x technically. Because
What is it?
2 sine, no, sine 2 of x is 2 times sine cosine. That doesn't work.
What are we talking about?
How do you use the double angle to simplify?
Is it sine squared? Kyle has his favorite card, so you should probably get them out.
What?
I'm good.
Jason got it, can you?
Oh,
No.
yeah, that
I
makes sense.
can't see, I'm behind the
That's
aisle.
so easy.
Okay, let me,
there's 2 times inside.
accordion forever card number 1, what is 2 sine cosine? Sine 2 theta. Oh, 2 sine theta, cosine theta is sine 2 theta. So if I separate the 5 and the 2, I'm going to have 5 times. 2 sine cosine will be sine double who? Sine double 5x.
Interesting.
Wait, I didn't.
Yeah, it's okay.
I don't know.
So if I take this, if I rewrite it as 5 times 2 sine of 5x cosine of 5x. 2 sine of 5x cosine of 5x. 2 sine cosine is the double angle of sine, but it's not double x, it's double who's in there, which is 5x. And so that's how we can go to 5 sine of 10x.
Hold on.
And that's from Forever Card 1. And Forever Card 1 says,
Oh, I got it.
AB had to review the double angle of cosine today. You guys needed to review the double angle of sine.
Is cosine, sine, or cosine?
2 sine cosine. I mean, they both have properties, but no, they're not the same.
Oh, it's right there.
So 2 sine cosine is sine double what's there. So the 2 sine cosine
I'm so proud, Caroline.
is sine double the argument. And the 5 is out in front because he's not a part of the formula. 5's extra. 5's extra. Alright, so that is the differential. How about this one? You guys see how I gave you tricky derivatives to do?
No.
You're welcome.
Oh, it's B to U. 1 over.
Nope. Product.
Oh,
Yeah.
Bulumbu.
Bulumbu.
Bulumbu. It actually helps. Second, D first. So 3 to the 2x plus.
Oh, B
Plus first. Bulumbu.
Do you guys know why Corey's randomly saying gibberish like that?
Yeah.
What's Bulumbu?
B to the U has this ln.
What? Bulumbu.
Limb.
ln of B times U prime.
Yeah, let's go. We got this.
Political practice. Excellent labor.
We don't need forever card, we just need gibberish.
What does
Bulumbu.
B to the
I could be a good sweatshirt club.
ln.
Pause! The AP would never have that be a make it match. What would they do?
They would simplify.
Yeah, right?
Pulling out a 3
Yeah.
2x.
They would pull out a 3 and a 2x. 1 plus 2x out of 3. That's what I would
Right,
say.
Lucy? Yeah, Lucy. Would they ever do an E to that? No. Take it rid of the L.
No, not really, because that would be rewriting. You don't have an equals on the other side. Like, it wouldn't really help.
Yokidoki, I'm joking.
You could have done ln of 3 to the 2x. Do you guys see that?
Yeah.
You could do that. It's the power property from pre-count.
Or ln of 1 times ln of 3 to the 2x.
Do you see it?
Right.
That could also be right. The 2x, because it's a power. Sorry, it's a product, and 2x could become the power. Anyway, just be aware.
I don't understand the point of just finding dy. Like, you're just finding the derivative and then.
Oh, well, remember,
Now you can take the interval.
it's, yeah, well, kind of. It's getting us ready for realizing that dy and dx can be separated. So that's basically what's going on. It's reminding you dy and dx can be separated, which will help with integration. But also, as we get to the next page, it might be a lot easier to find dy and be like, it's close enough, instead of finding delta y. Let me show. Here we go.
Okay.
Y equals x squared, true? Well, it's given, so yeah. Find dy when x equals 1 and dx equals 0.01. So we're going to go ahead and have 2 different objectives. One of them is dealing with dy. One of them is dealing with delta y. Okay?
Yokidoki, Richard.
Alright, ready, set, go. Talk it out in your groups. Don't be an island, don't do it by yourself. Because we haven't really reviewed how to do delta y. Although, isn't that just f of x2 minus f of x? What?
So then
This is really easy right
Yeah, change the real. Oh, you add it.
Oh, yeah, gosh, darn, I don't know how to do 2 times. Yeah, okay.
a team name? Team Corey.
Guys, that's our game.
Team Corey, that is.
And x equals 1 and... Hey, isn't it the same? Except for the different number.
What? Because the team name is 24K Matter. You don't like Bruno Mars? Wow, Lucy, why? Oh, I know why.
I
One
wasn't
of those.
super worried.
They're like that.
Okay, hold on. I wasn't super worried about whether or not you could do dy, so check that work. Do you guys agree?
Yes, ma'am.
Good. I was a little more concerned if you would be able to do the one that didn't need calculus.
I have it written. Isn't it, it's approximately dy.
No, but we're actually solving for delta y.
Yeah, but this one says delta y is approximately dy. So isn't it just close to 0.02?
No. Shh.
Then why am I confused?
You're solving for delta y to see the comparison and see if they're good approximations.
I don't know.
Delta x is a change in x.
So like, so x would be either plus or minus 0.012.
It is funny, Caroline.
Isn't delta y really just f of x
Change that big of a
minus,
difference?
well, f of x2 minus f of x1, like y2 minus y1. But in context, we have to say, like the definition of the derivative, it's f of x plus delta x minus f of x.
Hold on.
Which in this context, wouldn't it be f of, where are we starting, what x? 1, and how far off are we going from 1?
Oh, you okay?
No.
Does that make sense?
Oh,
Starting at 1, going another 0.01, so that's our x2,
so just
to find our y2.
So just screw it.
So it is going to be 1.01 squared minus 1 squared,
It's 0.0201.
and 1.01, I know, I'm just showing them. If you didn't have a calculator, use that scratch paper.
Oh my god.
So you have 1, 0, 1, you have 0, 0, 0.
Lol. It says
Zero.
lol.
There's so many zeros.
It
Oh my
says
goodness.
lol. And then it says lol.
1, 2, 3, 4.
It says lol. That's lol. I like it. It's lol, lol. It's also a person drowning.
Okay, pause. Stop being distracted. Yeah, similar. Okay. Question, is dy a good approximate for delta y?
Yeah.
Which one was more fun to find?
That
First
one.
dy.
The first one. Exactly, which is why, going back to Brendan's question, which is why dy can be helpful because it can help us approximate delta y. Now, what if this function was something like square root of x? What's the square root of 1.01?
Calculator.
Well, that's the point. What if you have to do it by hand? dy we can do by hand, usually, pretty well. But delta y can be just like these ones.
A little over.
Sometimes it's harder to plug into the function than to use the approximation that depends on the derivative. That's what's going on. Error. Error. Where have you seen error besides CalcBC?
Percent error.
Percent error.
Physics.
Oh my god. Yes, Kyle, we got that percent error. Remember that one time it was like 110?
Alright guys, we are horrible at talking and actually doing things at the same time, so shush. And right.
That's how I do everything.
All of you guys, but we're just not good at it. Most people aren't, to be totally honest. Including myself.
Depends if you think what you're talking about. If you just talk about it, that doesn't, it's not an issue. Talk all the time. It's
I-
Not that it can't
Why?
do.
Because I
I
played
talk about everything.
Animal Crossing. So.
No,
Yeah, but Right, totally focused.
No, your brain can have two things in the front seat. You have like Netflix in the back seat while you're having Animal Crossing in the front seat, if you get what I mean.
I get what you mean.
Yeah.
Not for it all.
Are you catching every single thing that's happening
Let's put that on our AP supposed
Like right
to.
now.
in Netflix?
Oh.
You know what I mean? Like when you're playing Animal Crossing, like you're catching everything. Like you're catching the main things, but what not, like Animal Crossing, what you're immediately doing is affecting how much you're paying attention to Netflix, or how much you're paying attention to Netflix affects how you play Animal
I can play cookie clickers and watch Netflix.
Wow, that doesn't require much skill.
Exactly. That's the point. So if you just talk without thinking, then it doesn't. Then it's not that big of an issue because the brain isn't working. It's only working with one thing.
But see, right now, with you guys talking, you're definitely like writing, but that's more of just a, you know what you're writing, but you're not really thinking about what you're writing.
Thinking about whatever.
If you're talking. Yeah, it's very easy to write and not think about it while not be copying, and focus on something else.
Yeah.
It's the same dilemma, except you're not distracting others as you're quietly being distracted.
I'm focused on Kyle's head because that's all I see in front of me.
Oh my god.
That's all I ever want to see in front of me.
Actually, it's a good question though. Why aren't you a lefty?
Because one foot makes that big of a difference in what he can and can't see.
Oh
Turn
boy.
his head this.
That'd be much nicer.
Okay, so let's remember number 3 on the board. Be considerate. Cool. Thank you.
Be real.
Nope.
Be considerate.
Honesty, I'm sorry, but could you please scoot a little?
Okay, so measurement error. Measurement error. Kiddos, that's like our delta y. Okay? Or I should say the propagated error is a little bit better. The delta y could be how far off. Because when you measure, you have an exact, well, here's an exact value, but you measure something here. This is what you measured it to be. But this could be how far off you were. And so if you subtract the 2, that's the propagated error. But the long story short, you guys know percentage of error from other classes, or most of you have dealt with it in other classes, where you take a ratio, a fraction of what you estimated, the measurement error in your estimate over the actual, like how far off are you actually? Like how much does that really affect what's going on? Like how bad is it? That's another way of thinking about it. Because if your measurement of something was like an inch, okay? And if you were a ½ inch off, plus or minus a ½ inch error.
Oh,
If you measured something to be an inch, and if your error was plus or minus ½ an inch,
it's pretty big.
that's a huge deal.
Yeah.
Because you would say, okay, I'm off by maybe up to ½ an inch, out of an inch. Isn't that 50% error?
Yep.
Okay. But what if you were maybe within ½ an inch and you were measuring something and it was like 20 yards?
That's pretty small. Pretty small.
Okay, so the point is not how much your plus or minus error is, it's how much it is in context or in relationship to the measurement that you guys are working with. So if this is the estimated measurement error over the actual, you can think the propagated error over the actual would be delta y over y, so we can approximate with dy over y, using what we talked about with dy and y. So we have the following. We have the following. Write down what's important. You guys know you don't have to write down whole paragraphs, but you should be able to read a word problem and to narrow down what's most important that you should be thinking of.
Really close to the
I think so.
Like, are we just doing exactly?
Oh.
Okay, so
It's the measurement.
Yeah, this.
I'm going to all right here.
So that's the change.
Okay, good help, Noah, go.
I want a function.
But you have a shape.
Pi r squared, 2 pi.
It's a sphere. 3-dimensional.
4 pi, 4 over 3 pi, 4 over 3 pi cubed.
R cube.
R cubed, my bad. So there's no pi?
You said pi.
4 over 3 pi r cubed. So then it's just 4 pi r squared.
You guys agree that volume of the sphere is kind of an important thing in this one?
Yeah.
All right, then I'll write down 4 is the same. Well, not all of it, but that part. What else do we know?
The x and delta x.
Radius is 0.7.
The measured radius?
0.7.
Plus or minus 0.01 inch.
What is that though?
That's
That's the
But
measurement.
how do we mathematically show that? I understand the plus or minus, and I totally
Or
agree with that, but
It's f of x
Delta
plus
R?
delta x.
No.
Nope.
I don't think I heard it. There is a
Delta
delta, the
V?
delta
Delta
V.
V?
Minus delta.
What did you say?
Delta V. I said delta R the first time.
Oh, delta R, that's the right one. I was listening to Gabby, sorry. I thought Sarah was there. Because it's how far off the radius is. Why could it not be delta V?
Because that'd be how far off the volume
What would the units be for delta V?
is. That'd be inches cubed.
Inches cubed. Inches are talking about the radius, even, because they said if the measurement is correct to within, they didn't tell us the measurement of the radius. I mean, it refers back to that measurement, but the units give us the clue. If they say estimate the propagated error in the volume, what are they asking for?
Delta.
Yeah, propagated error is delta y, but they're saying they're asking for delta y, but they're saying estimate, so what are we allowed to use? dy. Now, technically, hold on, but we're not doing y. It's-
But then what's
Exactly. We're trying to figure out the change in the volume, so we can figure that out. We can estimate that by estimating dV.
But-
But how do we find dV, dr, any of that?
4 pi squared.
We derive.
4 pi.
Okay.
So what is dV gonna equal?
R squared.
1.4
Good, 4 pi r squared d
R.
R.
Dirt.
Okay, let's
R.
4 pi times,
0.7 squared. Dirt. Wait, so dx is equal to,
So dr is
I mean, it can't be
equal to
negative.
delta R?
why not?
right. We'll talk about why dr and delta r can be the exact same if dv and delta v are just approximates
Okay.
in just a second. So now what? 0.7 squared, isn't that 0.49?
0.0616.
What? 0.49.
And 0.49 times 0.01, wouldn't that be 0.0049?
Yeah.
Wait,
Yeah.
why is it times?
Because you're multiplying it by a positive and multiplying by a negative.
Times
It's not plus or minus, it's a negative and positive.
Let's go.
Double check, 0.01, that's 2 decimal places, right? So 0.0049?
Wait.
And can I multiply that by hand?
Technically, yes. 36.
You guys agree? 0.0196?
Yes.
What are my units?
Inches. Inches squared?
No.
It's a rate, it's a rate.
It's
It's
volume.
a volume. Don't worry about rates.
Inches
It's a volume.
Inches cubed per
Remember?
cube per.
Inches
Cube
cubed
per.
per.
Nope, not per, because we're just finding dV, not dr, right? Now hold on, this is approximate to. How could we find the actual measurement error? We don't do this very often, usually we just approximate. How would you find the actual propagated error?
dy. Use the entire formula.
Delta y. Use what entire formula?
Volume x plus delta x minus f of x.
So you have your 0.7 inch and you could add 0.01 minus volume of. I didn't put a 0 there, that's kind of awkward.
It's 0.7.
It's 0.7.
Oh, thank you, thank you. Thank you, thank you. I got distracted, I was meant to put 0. And then I messed that one up.
Thank you.
So is it, do you always go with the bigger one, not the small?
Is it 0.7?
Yeah, because it's plus or minus, so positive, negative, so
What if we 0.71 in? 0.69?
actually I was just thinking that one, hold on. So if we're doing plus or minus. See this one, technically the plus or minus I didn't write, but it would be. You would state it would be within 0.0196 pi, which would be plus or minus. So we're just doing halfway and we're gonna say plus or minus. Does that make sense? Plus would be this error, minus would be the other direction, the same amount.
I
don't think so. Are you plugging in?
Yeah.
You gotta see what you'd have to do though. You'd have to do 4/3 pi times 0.71 cubed minus 0.7 cubed. Mathematically, what was easier? Multiplying 0.7 squared times 0.01 times 4, or cubing 0.71 and cubing 0.7 and subtracting.
The first one.
I think this one's mathematically simpler.
Because the original formula.
I'm plugging into the original formula, and I'm plugging in how far off it could be in a positive direction from the measurement. So I plugged in, and the 4/3 pi is shared in both, so I just factored it out. So then I had the r squared minus the r squared.
We're off by 0.002.
Oh, but where are the decimals? Sorry, I'm just gonna show those.
It's 0.0199 pi, technically. I divided by pi when I got the number.
Not too bad, pretty close.
Yeah. Yay!
But mathematically, I agree, I think this side is easier. Same thing with using the, I mean, do you guys get the point of this section?
You know, Kyle
We're talking about dy's and change in y's. We're talking about tangent lines and actual functions. Can I remind you really quickly why delta r and dr were the same thing? Is that okay?
Yeah.
Because after this, we're done. Ooh, maybe not totally done. Okay, ready?
Yes, ma'am.
The differentials are dealing with a derivative, true? A derivative is dealing with a slope of a tangent line to some random function. True? And we're talking about some sort of point of tangency. True? And when we're talking about a delta y, let me not even use this. Let me use this instead. When we're talking about a delta y, what we're trying to figure out is for some delta x, for some measurement away from the original point of tangency, the tangent line would say do this as it skims, right? However, the actual function would go up here.
So the difference is that area under the curve in between the lines.
Oh, I wasn't going that complicated.
Is that what it is?
Because we're not doing integration.
Is that what it is?
We'll just subtract there.
No.
No?
Because if we're trying to do dy to approximate delta y, dy says go to x plus delta x on the derivative. Dy is the change in heights, f of x plus delta x minus f of x, the change in heights, but not from one function point to another function point, but from one value on the tangent line to another value on the tangent line. So dy says, oh hey, if I was to go over this dx, if I was to go over this dx, I would go up to the tangent line. So the only thing that changes isn't how far over, it's how far up. Delta y would say, hey, for this
All the way up.
delta x, how far up would you go? So dx and delta x are the exact same thing. Because both of them are going over the same amount. Just dy says I'm going to the tangent line. Delta y says, no, 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 I'm going to the curve. Is that the two equal to each other? Why? But if they're never going to equal each other unless you're at the point of tangent. Except for rare cases, maybe. If you have some sort of like function that comes back down and just happens to hit the same point, but that'd be like a weird. Yeah, exactly. Okay, guys, you want to write down your homework?
Yes, ma'am.
Not yet.
Nope.
Workspace. 59, 60, 62. It shouldn't take you super long. But I do want to show you on these guys, do you see how there is a book question on something called Newton's method? Newton did a lot of stuff. Newton.
Didn't fall in his head.
Can I write in purple?
5.4.
Okay, workspace. We are in section 5.5 APMC. Okay. APMC. We're skipping 61 because we're not doing Newton's method.
Is this 5.4?
Why not?
5.5. 5.5 APMC. I don't remember if we come back to Newton's method as to whether or not we need it. I'm trying to remember. actually need to learn Newton's method. It is interesting. It's a way of approximating zeros. And Newton's method is interesting too because it says many calculators use the method. Use Newton's method because it applies to a wide range of functions and usually gets a result in only a few steps. With computer programming, the fewer the steps, the better. The more efficient the program, the faster the program. However, sometimes it fails, and sometimes your calculator fails in finding zeros as well. Wonder if that's wrong. So we might talk about Newton's method, but not today. And it's not necessary today. It's not just his one method, his only method. It's his method for approximating zero.
Is that true?
Yes. Hopefully it's all boys. $62 definition calculator, that wouldn't be a bunch. Figure out how far off divided by the actual.
Yeah, because they were actual numbers. You define
Of the error though.
Oh, yeah.
The actual. So the actual is the cube root of 66. The theoretical, we're not dividing the approximation, we're dividing how far off the approximation.
Where's the D? Don't do that.
Oh, yeah.
It is B.
Oh, that's why.
So the error divided by the actual. Does that make sense?
Yeah, because it was like a chemistry.
Oh, no.
Like, the formula just that it's over like theoretical, like quotating, and it like completely threw me off. And I was like,
Yeah.
And then today in class, like we did the problem and she put it over and what we got was like she did it by accident.
Oh, so it wasn't on
That threw me off
purpose.
again.
Right, because it solidified it in your head, which is wrong.
Yeah.
Yeah, it'd be the theoretical minus the actual. All the actual is what we just did.
Yeah, okay, thank you.
Did anybody actually divide that? Is it 4 and 1/24?
Yeah.
Okay. And you got?
Yeah.
0.080105.
What?
Okay.
Is that the ratio? 95.
Misty?
This is the percentage error. And that is based on, Gabby, I'm coming back. Y minus 4 equals 1/3 cubed root of 64 squared times x, no, times 66 minus 60.
Misty, I literally just put in what you put and I got 95.9% error.
How did that happen, kid?
By the way, never mind, that's the way.
Right, so that'd be 16, 48, 2 over 48 is 1 over 24, 4 and... Wait, was it wrong or was it right?
No, I got.
I think you did 4 times 1/24.
Yeah, you do
Yeah,
that.
4 times.
You do that.
No, it's
4 and 1/24.
So like 4 plus 1.
Oh, that would be it. Because you would have done 1/6.
Oh, yeah.
Kiddos, how did the other ones go? Did you get B and D?
Yeah.
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 How did you get D for 60?
Because you need to do dy is equal to secant squared x dx. So then dy is equal to 1 over cosine of pi squared times 0.5. Cosine of pi is -1. Squared would be a positive 0.5. Any other questions on these ones? I don't think so. I've killed it with not many objects. Not it as in one, but it as in, anyway. You guys want to take a picture of homework?
That makes so much sense.
Just, I thought it was due today.
Go team!
Why did you all think it's due today? We didn't even finish notes.
Yeah, I know.
No. I didn't have a due date. Yeah, I didn't have a due date.
I checked the whole picture. We're gonna do this.
If you guys want it, there it is.
Finish my notes.
Section 5.5 is now done. Section 5.6 is, Corey, you ready? Related rates.
Yes. I like when they would have this. It's my favorite thing in calculus.
I wonder if it's gonna make me cut off.
Why do they make related rates?
No, we have.
Hey, if you cut off your hair? No. Please? No. Come on. Don't you want too much more right now? No, the people who actually need it.
Because I have a midterm.
Yes, because you need it more than kids who have cancer. The bulb looks in right now. Yeah, you.
Thanks for
Yeah,
coming.
hey, do you have a tumor in your mouth?
Yeah.
No. I have.
Alright, kids, once you get the homework, you have 15 seconds to the bell
Who
rings.
cares about that?
Come tomorrow with questions and fully attended as much as possible. 10 people. My honest running. 10 people. What? Yeah.
Her tumor is not your tumor. If I were to bring it up, you would bring it up, right, Mr. Will? He would open it up. I got something to tell you. Just ask him what he has to say. The word was floods.
FLEBS? Oh, that makes more sense.
Do you have any friends from the DR? Because I heard you're out there and like I don't know.